Hi, grade 10. So we're going to wrap up this factoring unit. I'm just going to do a quick snapshot before you go online and try your test. So today we're going to start with what we started with at the very beginning of the unit, which is the prime factorization of 840. Okay, so here we go. We're going to do this together. And I told you could do factor trees or factor ladders. Many of you like the factor ladder situation, so we're going to do that. So 840 divided by 2 is 420. We come back. Remember, my big deal was you pick the smallest prime number every single time. Again, reminder, our prime numbers are 2, 3, 5, 7, etc. Okay, so we're going to get all of our 2's together this way. 210, bring this back here. 210 divided by 2 is 105. 105 is no longer divisible by 2, but if you try 3, that works out. 35. 35 is now divisible by 5. And then lastly, remember we always have to end with 1 here. So here's our list of prime factors of 840. And if I ask you to write them using prime factorization, what I'd like you to do is use exponents. So 2, and there's 1, 2, 3, so 2 cubed times, there's only 1 3, there's only 1 5, and there's only 1 7. So that would be the perfect way to write the prime factorization of 840. Okay, so the next thing we did was determine the greatest common factor of sets of numbers, and we had a quick, easy way to do this. So we always started with the factor ladder, factor tree. That's what we found helpful. The 2 will go in there 75 times, and now 75 is not divisible by 2, but 3 will go in there 25 times. 25 is no longer divisible by 3, but 5 goes in there. And remember, when we're doing these factor ladders, we always have to end with 1 here. So here's our list of prime factors of 150. Then if we moved on to 275, 275 is obviously not divisible by 2, and if you try 3, that won't go in there, but 5 does. 55 times, bring 55 back here, that's also divisible by 5, we get 11, and then you should recognize 11 as a prime number. We get 1, there's our list of prime factors. And now we're going to try the bigger one, which is 420. 420 is divisible by 2, you get 210. 210 is even, so it's obviously divisible by 2. You get 105. 105 is no longer divisible by 2, but 3 goes in there 35 times. 35 is divisible by 5. And then 7 is divisible by 7, and you get 1, and here's your list of prime factors. Now, if you remembered, how do we find the greatest common factor? We find the greatest common factor, and remember, my little mnemonic was go fish. So you're looking for numbers that show up in all of the lists, okay? So what shows up? There's a 2. Well, a 2 shows up there, but it doesn't show up here. It shows up here, so it's got to be common to all of them. Let's try 3. 3 shows up here, but not here, so that won't work. And so now we'll settle on 5. 5 shows up here, here, and here, so that's 1. And then if you take a look, that's the only factor that shows up in all 3. So the greatest common factor of 150, 275, and 420 is simply 5. Okay, so the next question was find the lowest common multiple. And I've given you 4 numbers here, but they're pretty small numbers, so this should be straightforward. So again, we start with the factor tree, and 5 divided by 5 is 1, and so there's our factors. And now let's try 20. 20 divided by 2 is 10. 10 divided by 2 is 5. And lastly, 5 divided by 5 is 1, so there's our list of common factors. Okay, next number we're going to try is 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. And lastly, 3 divided by 3 is 1. There's our list. Okay, last number, 27. Not divisible by 2, obviously, but divisible by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. And there's our list, 3 3s. So it's kind of the same start, but then lowest common multiple is a little bit different. We write down any number that shows up in this list. So we've got 3s. Oh, sorry, we've got 2s. Let's put them in order, numerical order. 2s, 3s, and 5s. And now we're going to go back and we're going to look for the largest degree, greatest degree, or the biggest amount. So let's start with our 2s. Where do we find the biggest group of 2s? Right here, there are 3 of them, so we're going to write down 3 cubed. And now we go back and we look for the largest group of 3s. We can see it's in 27. We get 3 cubed. And the biggest group of 5s, well, there's just 1. We don't have to write the exponent, but we can. Okay, so now we're going to work this out. 2 cubed is 8. 3 cubed is 27 times 5. So if we multiply this out, 8 times 27 times 5, then you should get that the lowest common multiple for all three of those numbers is 1080. And that's much easier than writing out all the multiples of 15, all the multiples of 20, all the multiples of 24, all the multiples of 27 until we got to that. That would be crazy. Okay, so now we're going to do the actual factoring, and this is just a quick snapshot. You're going to have to go back in your notes, you're going to have to revisit, you're going to have to text me or put some questions up on Google Classroom if you don't remember. So this first question is simply a product sum. Okay, it's a trinomial. This is not a perfect square. There's a coefficient of 1 here, so we're looking for two numbers multiplied together give you 54. If we add them together, we get negative 15. So we know that both the numbers are going to be negative. Okay, and when we work this out, we're going to get negative 6 and negative 9. Multiply those together, positive 54. Add them together, you get negative 15. And this is a nice simple one. X minus 6, we just take that factor as it is, and x minus 9. Moving on over here. Okay, as soon as you see four terms, you should think squiggly line. So now we're just going to do a greatest common factor of the first set and a greatest common factor of the second set. It's a greatest common factor of 3a cubed and 3ab squared. I can take out a 3 and an a, and I'm left with a squared plus b squared. I take the sign that is sitting here, plus, what can I take out of these? I can take out a 2, and I can take out a b. I'm left with a squared plus b squared. And how do you know you're right? Well, as soon as those brackets show up the same, then you know you're right. A squared plus b squared becomes one of the factors, and the stuff that's sitting on the outside becomes the other factor, and then you're done. And if you multiplied these back out, distributed, you'd come right back to the same answer as there. All right, here we go. It's a trinomial, but this is not a perfect square, neither is that, and we can't take out a greatest common factor. So this is decomposition, or what I call circus tent. Our new product is negative 15, and our sum is positive 2. So when we work that out, we're going to get negative 3 and 5 are going to be the two factors. If we multiply those together, we get negative 15, but if we add them together, we get 2. Now this is a little bit different than the one we did up here because there's a coefficient. We're going to break down that middle term. So we're going to get 3x squared minus 3x plus 5x minus 5. We just took these two terms and we decomposed that middle. And now you see we have four terms, so we're going to do a question like this. What's the greatest common factor of 3x squared and negative 3x? Well, a 3 and an x, and we're left with x minus 1. Okay, we take the sign that's sitting here. The greatest common factor of 5x and 5 is 5. We're left with x minus 1. How do we know we're right? These two are exactly the same. We write that down as one of the factors. The stuff left on the outside is the other factor. Go back and watch my video on factoring by decomposition if you don't remember this. This here now, it's a trinomial. This is a perfect square, this is a perfect square. Half of 16 is 4x. If we square that, we get 64x squared, or 8x, I'm sorry. Half of 16x is 8x. If we square that, we get 64x squared. If we multiply this and this, we get the same thing. Shortcut is, okay, square root of x squared is x. The sign sitting here is a positive. The square root of 64 is 8. And then we just need to remember to put the square sign out there because we always need two factors. If we factored that out, we would get x squared plus 16x plus 64. Last one, difference of squares. We know that it is this type of factoring because there's only two terms. It's a binomial separated by a subtraction sign. Perfect square, perfect square. How do we do this? Find the square root of x squared, which is x. Find the square root of 64, which is 8. We make one of these positive, and we make the other one a subtraction sign, and that negates that middle term, and that's how we get back to a binomial. Okay. I'm going to post this, and I want you to try it, and then you can compare, come back to this, and see if you're getting the same answers and getting them the same way, and I will talk to you soon.